to solve an exponential equation by using substitution and quadratic factoring. Substitution, yay, that means you need to begin with let u equal. Now let's look at the equation and see what u needs to equal. Here I have a 2 to the 2x, and here I have the 2 to the x. That means that if I let u equal 2 to the x, then u squared is equal to 2 to the 2x. Right? Okay, so using u's and rewriting my original equation, I have u squared minus 8u plus 16 is equal to 0. And that is a perfect square trinomial, so u minus 4 squared is equal to 0. Or in other words, u is equal to 4. Now, we're not looking for u, we're looking for x, right? 2 to the x is equal to 4. 2 to the x is equal to 2 squared. X must be equal to 2. I came out with only one solution here because I had a perfect square trinomial, but that isn't always the case. You do, however, have to worry about domain. I'll work another example here real quickly. If I had 2 to the 2x plus 8, 2 to the x plus 16 is equal to 0. And let u equal 2 to the x again. This would be u squared plus 4u plus 16 is equal to 0. Plus 8u. Or in other words, u plus 4 squared is equal to 0. Well, that means u must be equal to negative 4, which means 2 to the x is equal to negative 4. And that's not possible. Exponential functions don't fall below 0 unless we have some sort of negative leading coefficient. If I had 2 to the x minus 4 times 4 to the x. No. Start that over again. If I had 2 to the 2x minus 4 times 2 to the x plus 3 is equal to 0. Note that that could also be written as 4 to the x minus 2 to the x plus 2 plus 3 is equal to 0. So the substitution here isn't always perfectly clear at first glance. But let's go with this original statement. And I would let u equal 2 to the x. So u squared minus 4u plus 3 is equal to 0. And in that case, u minus 1, u minus 3 is equal to 0. So 2 to the x is equal to 1. Or 2 to the x is equal to 3. And this would be x is equal to 0. This one isn't so pretty. Take the log of both sides. Or in other words, x log 2 is equal to log 3. And then x is equal to log 2, or log 3 over log 2. Right? So there are a lot of different options for these types of problems.